20 done. Let's go to 21 now. A vertical pencil of rays comes from the bottom of a tank with a liquid. Okay, when it is accelerated horizontally with an what? You mean the rays? Are you serious? Acceleration of 7.5 meter per second square. The ray is seen to be totally reflected by a liquid surface. What? Horizontally. Wait, what? So it's going in a circle, I guess. Huh. Bottom of a tank filled with a liquid is accelerated horizontally with an acceleration of something. The ray is seen to be totally reflected by the liquid surface. What is the minimum possible refractive index of the liquid? I don't understand this. It's supposed to be accelerated. What? And it's just horizontally. So, what are they talking about? Okay, it's like it's changing its direction and then it's going. Oh, so it's. No, it makes no sense. It's not making sense. How would that be happening? Minimum possible refractive index of liquid. Okay. I mean, the only way this could be actually, accelerating horizontally is that the index changes, right? Index changes as we go up. So then, which index are we talking about? When this said minimum possible index of the liquid, at what part? I don't know. This seems like what kind of question is this? It's just first of all, you cannot accelerate. You cannot accelerate light, right? First of all, you cannot change its velocity in a particular medium, right? You can only change its direction, and that too, not just normally. How would you do that? I get it, it's a hypothetical, but if we just assume that the acceleration is completely horizontal, let's know. I mean, like that velocity in the vertical direction is constant. Well, no, it's not correct because that would make the speed of light in this a variable, which is not correct, man. We know speed of light must be a constant. If it's a variable, this makes no sense. So yeah, I mean 21 I'm just not going to do because it makes no sense. Right? How could it make sense? What's a vertical pencil of rays? So okay, how does that change anything? So you might be thinking, okay, like maybe the rays are diverging because they are diverging, and that's why we think that they are accelerating horizontally. But still, it's at a constant rate, right? It can't be accelerating in the medium. How would that even happen? The ray is seen to be totally reflected by liquid surface. Nope, just not doing it. 21 doesn't make any sense. 22. Two identical thin isosceles prisms of refractive angle A and refractive index mu are placed with their bases touching each other. Okay, prisms, fine. Two parallel rays of light are incident. So these are thin prisms. Nice. Two parallel rays of light are incident on the system as shown. Distance of the point where the rays converge from the prism. Oh, right. So whenever they will intersect. First of all, what's the deviation? Just like a times mu minus 1. So you deviate by that. That's our angle now, right? So you have the distance between these is just 2h, right? Initially they're pretty much like going parallel, and now they suddenly go like this. So with a small angle over here. So this angle is just a times of del minus 1. Sorry, mu minus 1. Yes. Okay, and then these are gonna meet somewhere over there. Of course, it's symmetric, so this has to be height h. And then they want how far away will these meet. So this distance will be x. Of course, h upon x, which is tan of this angle, is approximately equal to this angle. So yeah, x is just equal to h upon this angle. So h upon a times of mu minus 1. Where is it? It's at C. So 22C. Okay, 23. So what's 23? 23 is a concave spherical surface of radius of curvature 10 centimeters separates two medium x and y of refractive index 4/3 and 3 upon 2. Okay, if the object is placed along the principal axis in medium x, then image is always real. Image is real if the object distance is greater than 90 centimeters. So object is real, right? Image will be real if your image is actually formed to the right of this surface, and if it's not, then it's like virtual. Yes, yeah, that should be the thing. So first of all, mu minus, so mu upon that, right, it's gonna be like 3.2 upon v minus 4 upon 3 upon u is equal to 4/3 minus 3 upon 2, which is like, what's this, 8 minus 9 is negative. Wait, what? No, it's going to 3 upon 2 minus 4/3. Sorry, that's going to be 9 minus 8 is 1 upon 6, right? So it's going to be 1/6 upon the radius of curvature. So 1/6 upon. Okay, that's negative. So negative r. Yes, that should be the thing. So what is your v in that case? So divide. So multiply by 2/3. Only 1 upon v is equal to, so 2/3 of 4/3. Yes, that's just 8 upon 9. It's like 8 upon 9 not upon u. So 8 upon 9 u. Okay, and then this is like minus 1 upon 6 r, but then you got 2/3 actually, so it's going to be 1 upon 9 r. Does that make sense? Because it should. Really, like, yeah, okay, it does make sense. So this will be like 1 upon 9, and you got 8 upon u minus 1 upon r. So sometimes v is positive, sometimes negative. So whenever u is, when is v negative though? So right, just figure out when is this v negative. So for v to be negative, 8 upon u should be less than 1 upon r. So, oh wait, okay, you know what? U is negative anyway, right? All of the time. Yeah, it's a real object. It's not imagined. Sorry, it's not virtual. That's why it cannot be positive. So that means this quantity is just negative. So v is negative, and there we go. It's always going to be virtual, right? So what's this with 90 centimeter? Right. So radius of curvature 10 centimeter, and that's why. Once again, what is this with 90 centimeter? I don't understand this. Did I mess up somewhere? It's supposed to be this minus that, right? So, yeah, that's clearly just 1/6. Okay, then you got 2/3, so it's 1/9. Yes, that's correct. That's just correct. Then u is negative. So yes, v is negative all of the time. I don't get it. What does this 90 centimeter have to do with it? 90 centimeter. Maybe they're talking about like the focal length, So what's the focal length? It's going to be, yeah, this quantity. So just accept that actually you just have now 2/3 over there. Okay. Something like that. I don't know. Why would you have this 90 centimeter arbitrary thing? Okay, that's it. What's going to happen? Oh, they're like two different questions with the same thing. Okay. Wait, aren't these just copies of the same thing? Oh, they are. They really are. 23, 24 are the same thing. Okay. Except this is like capital X and capital Y. But once again, refractive index. Oh, these are different now. So now X has refractive index of 3 upon 2 and Y has 4 upon 3. Previously it was different, right? Okay, that's understandable. So for the first guy, it's always virtual. Yes. So 23rd C. What about the 24th guy? So for this, yeah, like V and U shift. So just have, yeah, whatever, like 4/3 upon V minus 3 upon 2 upon U is equal to, it's going to be negative 1 upon 6, right? Yeah, now it's different. So it's going to be just 1 upon 6r like that. Yes. And now it's gonna do 3/4 of the stuff like 1 upon b. Uh, so 3/4 of that like minus 9 upon 8. 9 upon 8 u. That's equal to, so 3/4 of this. Uh, is that correct? I think it is. So yeah, it's going to be 1 upon 8. 1 upon 8 r. So 1 upon b is just 1/8 of 9 upon u plus 1 upon r. So yeah, in case u is smaller than -90, that is distance is more than 90 centimeter, this thing will be negative. So it's virtual if object distance is more than 90, and it's real if it's less than that 90. Right, that makes sense. Now, real if distance less than 90, yes. So 24th d. Okay, so that's why this 90 centimeter was there, right? 25. 25 is when the object is at distance u1 and u2, the images formed by the same lens are real and virtual respectively, and of the same size. And the focal length of the lens is, so object is at distance u1 and u2, the images formed by the same lens are real and virtual respectively, and of the same size. So oh, it's like the magnification is just +1 and -1 in these two conditions. Yeah, but what's the magnification though? So it's a lens, right? So 1 minus v, 1 upon u minus 1 upon u is equal to 1 upon f. Magnification is like v upon u, of course. So you need to do that. And it's dependent on the object distance. So you gotta multiply by u, I guess. So u upon v is equal to 1 plus u upon f. So what you're saying is this u upon v thing, inverse of the magnification, it's 1 for u1 and -1 for the other guy. Yeah, okay. Oh no, these are of the same size. They're not saying these are 1 or -1. Wait, or are they saying that? Oh yeah, I don't know. Focal length of the lenses. Well, one thing we know for sure is that the magnifications are opposite of each other, right? That's one thing we can say for sure. So this u upon v ratio should also be negative of each other. Yes. So that just means 1 plus u1 upon f plus 1 plus u2 upon f is equal to 0, because additive inverses, right? Yeah. So 2 is equal to, like -2 is equal to u1 plus u2 upon f. There we go. Seems reasonable. So the focal length will just be negative u1 plus u2 and upon 2. Oh, these u1, u2 things are actually distances, not oh, right. So instead of that, we should have negative over here. So then it's going to be positive 2. And that's why it's going to be u1 plus u2 upon 2. So the mean of these things. So 25th b. Yeah, that should do it, I guess. Okay, next. 26. A thin lens of focal length f and its aperture has diameter d. It forms an image of intensity I. Thin lens of focal length f. Okay, aperture is given. Forms image of intensities. Whatever. Now the central part of the aperture up to diameter d upon 2 is blocked by an opaque paper. Oh, the focal length of, okay, and the intensity. So focal length doesn't actually change, you know. Yeah, why should that change? Yeah, it won't change. Just the intensity will change. So it's how much of it did you cover up? Okay, only did d upon 2. So 1/4 of the lens is covered. That just means intensity is like 3/4 of what it should be. So it's f and 3i upon 4. So 26d. Okay, 27. An object is yeah, I mean that's pretty much correct, right? Yes, an object is placed in front of a thin convex lens and focal length 30 plus 30. convex, and a plane mirror is placed 15 centimeter behind the lens. Okay, so yeah, if the final image of the object coincides with the object, right, the distance of the object from the lens is right. So wait, final image coincides with the. Oh, that's weird. I mean, we can of course figure out what the final image should be. So first of all, let's do lens formula. So yeah, just got 1 upon v, say u1 is equal to 1 upon u naught plus 1 upon f. So basically, u1 is equal to u naught f upon u naught plus f, right? Now, you know what u1 is. How do you reflect about that mirror, which is now at distance? Let's just say d, right? So said it's d equal to 15 centimeter. Focal length is positive 30 centimeters. Yes, in sign convention. So u1 minus d is as seen by the mirror. Now negative of that thing is going to be d minus u1. So d minus u1 and that thing plus d. So 2d minus u1 is what we look for. So 2d minus u naught f upon u naught plus f. That is the image that, sorry, the u2 thing, of course. And now using this, you'll find u3, right? But for that, u3 take a focal length to be negative. Oh yeah. And wait, the good thing is that this will actually form an image that is at the same u value as u naught, right? Right. So yeah, I mean, like you can use retraceability of light or something. But first of all, just write down the equation. It's got 1 upon v is u naught minus 1 upon u, which is like u2 in this case. That's equal to negative 1, right? Remember, negative 1 upon f or something, right? So this is almost like 1 upon u2 minus 1 upon u naught is equal to 1 upon f. But guess what? What is this? Then it's just equal to u1. So this whole thing is just equal to u1. But what's u1 is equal to that. So that just means like d is equal to u naught f upon u naught plus f. That's what it says. Like 1 upon d, that must be equal to 1 upon u naught plus 1 upon f. It's almost as if u1 was d, right? So u1 was d, which means the first image was formed at the pole of the plane mirror, which, okay, that makes sense. Perfect sense. Yes. So what's the distance? It's just like, yeah, just put that in there. You will get the u naught value. So 1 upon u naught is equal to 1 upon d is 15. That's like 30. Wait, why is this? No, it's not right, because this is bigger than that, but we know like u naught should be negative. So what's going on? No, it's not right. How could this be right? Ah, okay, u2 is equal to u1. Perfect, right? u2 is equal to u1. I get that. This will happen when d is a, right. Must have messed up somewhere. But this is clearly correct. And d is 15 centimeters, but the focal length is 30 centimeters, right? Then how could this happen? Even parallel rays are just converged to 30 centimeter. So if you want to get even closer to the center than that, you will have to have converging rays put in there, which makes no, I mean, okay, for that to happen, the object must be something like a virtual object, but that doesn't make any sense. And lens, the final coincides with the object. Maybe there's like two different. No, I don't get it. This equation clearly says that u2 and u1 are the same. Yes, but for that to happen, this equation should hold, and then, oh god. Something makes sense. Okay, what if we did take that possibility of it being the thing would be that this convex lens and the mirror would have the object between them for this to happen, coincides with the object. Plane mirror, right? How could this be wrong? I don't get. Yeah, like the only way is like it's at the pole of the plane mirror. For that to happen, this equation must hold true. U naught must be negative for it to even make sense, but then U naught is not negative over here, right? So T is equal to 15 centimeter and then focal length 30. It's not making sense. It's just not making sense. Yeah. This is like, okay, what if this was like virtual? So, but then, no, okay, if this was like virtual, then that would be not good. That would be good. You know, first it's going to get refracted by the lens, form an image, then that will, right, get reflected by the mirror to form another image, and that image will finally be reflected by the lens once again. And that will be our final image, right? Yes, that's the thing. So, I'm losing it. I don't know, this seems incorrect, you know. 27, I don't know. I don't know how to do it. Is the assumption okay that it's like negative? That it should be positive? Like U naught is equal to 30 centimeter. That makes no sense, right? Because it's even beyond uh, the plane mirror, which is not correct. That just cannot happen. So yeah, there we go. This is just wrong. What if it's between a focal length and then okay, what if that happens? What I'm thinking is, okay, you got this lens. If it's between the focal length, so less than that, then you will have an object at, so it's going to be virtual object, and then you will have somewhere over there or something, and then you got this plane mirror. Well, it's definitely not over here. It's going to be somewhere over there, and then that object will form this, right? It's already not at infinity, so it's not even going to be, it's going to be after the focus. This was not good. That means there's no way for us to get the thing done. Yeah. What if it was at the focal length itself? Then you would have an infinitely far away object over there, and then this is also like infinitely far away, so it's gonna go to the focus. Makes sense. Makes sense. Right, I guess the focal length is the thing that we should use, because right, whenever it's the focal length, it's gonna become path. So how does that show in your equation? That, right. What was the equation? Yeah, well, with normal finite values, it's not making any sense. So there's only one other thing that you can do. Go to that kind of condition where, yeah, these are not finite anymore. So, right, these are approximately at the same point, but that as it goes to infinity, it just actually becomes at the same point. So the focal point is the only point where this is gonna happen, I guess. Yes, I'll just put that as the answer. So 30 centimeters from the lens. So 27B. This isn't shown in our equations because actually it's never going to happen. It's a limiting case. So the distance between the objects, between the object and image, it will start to decrease and go to zero as your object actually approaches the focal point. Yes. Yeah. Right. So the thing is, like, it's at infinity. These rays are just completely parallel. Usually, that's not what we deal with, right? We have a finite distance, and then, yeah. But at this point, the reflection, so that doesn't actually change the distance from this lens of our image. Yes. And that's why it still goes to focal point. I know it actually changes, but then it's infinity, so it doesn't matter. So yeah, that's why it should be at the focal point. This is crazy. I never thought I would have to resort to these kind of things. But fine, if even guessing works, it works, right? Let's go to 28 now. An opaque card is held over the lower half of a converging lens as shown in the figure. So, card, lens. What picture is uh, what picture best shows the image that appears on the screen? Well, okay, this is just wrong. A and B, I don't think that's correct. D might be the thing. So it's more than the focal distance, and that just means, yeah, but I guess it's also more than the 2F thing or whatever. In the end, it's just not virtual, it's real, and that's why it's going to be inverted. So D looks correct, I guess. And of course, it's going to be full image. It's going to be the full image. It's not just the lower half that can, yeah. Okay, so 28 D. 29. When you sneeze, squeeze the lens. Oh, so paragraph question. A turn, what? A turnip sits. Okay, this is a turnip. Sits before a thin converging lens. Outside the focal point of the lens. The lens is filled with transparent gel so that it's flexible. By squeezing it towards, it's like the eye lens. By squeezing it, its end, and towards its center, as in you can change the curvature of its front and rear sides. Front and rear side. What does it mean? Oh, it's like this and that, huh? Okay, when you squeeze the lens, the image. So we know as we squeeze this, its focal length, its power basically will increase because curvature increases. So your focal length will actually decrease. Yeah, whatever. But since its power increases, like okay, this point, so it's going to become more and more converging. Yes. So it will form a nearer image, I guess, right? You know, I mean, like 1 upon V is equal to 1 upon U plus 1 upon F. As your focal length decreases, your 1 upon F is going to increase, right? And then assuming V is actually positive, which I think it is, right? It's not virtual or anything. So your V is positive anyway. So as your 1 upon F thing increases, your 1 upon V, it increases in magnitude. So your V also decreases actually. And that just means it's, yeah, it's like moving like this, right? Towards the center. Yes. So it moves towards the lens. Yes, the image will move towards the lens. Shifts up, remains as it is. Shifts up. I mean, yeah, the image's height will actually kind of like decrease because your V is now smaller. Oh, it will shift up. The thing is, it's also inverted. So yeah, as this is getting smaller, its height, although it's decreasing, it's actually going up. So right, it will shift up and also it moves towards the lens. So I think A and C, but do we have multiple choice? It's single choice, right? All of this exercise was single choice. So I'm gonna go for A. It moves towards lens. Right, so 29th A. Uh, 30. Sorry, wait. Yeah, actually. The lateral height of the image. Right. So the height decreases, although actually it's like going upward. Ah. So B. Suppose that the image must be formed on a card which is a certain distance behind the lens. While you move the turnip away from the lens, then you should. Okay, so you're moving it away, so such that this still actually forms over here. Okay, okay. So we know that in this case, 1 upon V is constant, and then focal length is varying. So 1 upon V is equal to 1 upon U plus, or just go with negative 1 upon U. So U is negative in any case. Just say it's like at X distance away, D distance away. So 1 upon D, and then, wait, I think you already have the distance. And just say, okay, so from here to here it's capital D, from here to here it's small d. So 1 upon D is equal to, so it's got negative 1 upon, which is like negative 1 upon capital D, and then focal length, which is changing. Now, clearly, D is supposed to be positive, right? Because that's how we define it. So, uh, as your d increases, this complete thing should decrease. So 1 upon f should also decrease, right? So for that to happen, f should increase. In other words, your curvature should decrease. So you should release it little by little. Decrease the squeeze of the lens. Yes. Increase the squeeze of the lens. Move the card away from the lens. I mean, yeah, I guess you could do this thing. Move the card away from the lens. No, wait. Why would you move the card away? You would move it towards the lens, right? Keep the card and lens head. Okay, that won't do anything. That's just failing very hard. Increasing this. No, okay. I think A will work. Then of course, like okay, as this thing is decreasing, you could just try to increase your 1 upon d. In other words, you decrease your capital D, and that's one thing you can do. But that's not in the options. They only said move the card away. So you should move it towards lens. So 31 done. Let's go to 32. A light ray hits the pole of a thin biconvex lens as shown. The angle made by the emergent ray with the optic axis is. So it's 2 degrees and then it's. That's new, that's 2 new. Oh wait, this changed, huh? This just changed. Oh, that's unexpected. The angle made by the emergent ray. The thing is like this ray is just hitting at uh, this part, so that's almost parallel right there, right? So if I just take like a very zoom in of this thing, so like this is thin as well, so this distance is like not that much, so it's going from mu to 2 mu and then to 3 mu, so it's shifting, right? Shifting like this. Oh, that's just exaggerated. Yeah, this should do it. Okay, so yeah, I mean, okay, I understand what's happening. What should happen is like sine of whatever this angle is, so sine theta and that times of 3 mu, that should be equal to mu times of this angle. So sorry, sine of that angle, sine of 2 degrees. So really, and because these are like so small, you might just use small angle approximation. So in radians, whatever this might be. You know what? Yeah, skip that. Since radian to degree conversion is like linear anyway, you can just write this equation 3 theta degrees. So yeah, I mean, if theta is in degrees, just have 3 theta degrees is equal to 2 degree. Yeah, approximately. I know. Actually, it should be in radians, but whatever. We'll just deal with degrees like that because it's linear. Come on. I mean, you put it in radians and everything, and then you have to go back 2 degrees. That's just so hectic, right? Just don't do that. Yeah, easy as that. Just don't do it because it's going to be just a magnified version of the radians anyway. So, this works as well, right? So 3 theta degrees is equal to 2 degrees. So theta is just 2/3 degrees. Yes, exactly. So there we go. Or you could just say, okay, like 1 degree is kind of like a unit. It's not a number. See, so 2 degree is not a number anymore. It's just some kind of unit. Then instead of doing this thing, we just say theta, and then that would be like theta. So 3 theta is equal to 2 degrees. And this would be a very correct equation, approximately, of course. So first, first degree approximation. 3 theta is equal to 2 degrees. Theta is equal to 2/3 degrees. There we go. So 32, it should be C, I think. Okay, let's go to 33 now. So a concave mirror is placed on a horizontal surface and 2 thin uniform layers of different transparent liquids which do not mix or interact. Concave mirror is placed on concave mirror is placed on a horizontal surface. How? Okay, so like this. Okay, 2 thin uniform layers of different transparent liquids are formed on the reflecting surface. You should really give me a diagram. formed on the reflecting surface. What? Right point source of height h. Okay. What do you mean by all of this? Like, what are they talking about? Formed on the reflecting surface. Form layers of different transparent liquids are formed on the what reflecting surface? Like there's no reflecting surface. Are you crazy? Okay. Uh, we have some kind of interruption now. So I think we should stop. Yeah, it's a shame. Like it's just so little questions left. But I think we should stop now because I have some other stuff to do. So see you guys in the next video.